So we're going to do example C from lesson 3. When we're finished our example, we want to make sure we can actually draw a sketch. So that's a little bit different than what we've done in the past. We want to be able to sketch what we have here. Critical numbers, again, or hopefully we understand there's critical numbers for our slopes. Where is your slope equal to 0? Where is your slope undefined? There is no undefined in this example. And the reason being there's no undefined, you have no square roots of negatives. You have no divide by 0. So the only critical numbers you have to find are where we're equal to 0 at. Notation. It's function notation, so let's use function notation for our derivative. We kind of fixed the question so the fractions go away. 1/3 of 3, so our derivative x squared. 1/2 of 2, so that becomes an x, and minus 6, and then derivative of 1 is 0. So we want to find critical numbers. No dividing by 0. But again, some of us struggle with communication, and we want to make sure people can follow what you're doing on your page. So don't leave a bunch of gaps in here. Critical number, where is our slope 0? We're just going to factor x minus 3 and x plus 2. So we know our slope is 0 where x is 3, and our slope is 0 where x is negative 2. So that's the kind of things we want to show in regards to the first derivative. We can use our first derivative test to find regions of increase and decrease, and then based on that information we can figure out whether you have maximums or minimums. But we want to talk about points of inflection here as well, so we do have to do a second derivative. So let's do the second derivative idea, where you're looking at whether you're at the top of the curve or bottom of the curve, and combine two thoughts to figure out whether you have local maximums or minimums. So again, the first thing you've done only is you found where your slopes are 0. So that's kind of thought number 1. These are your slopes equaling 0. Second thought now, my second derivative. So if I go back to my first derivative, take a derivative again of that. So the derivative of x squared is 2x, and then the derivative of negative x is negative 1, and the derivative of 6 is 0. So I want my critical numbers this time again. There is still no dividing by 0. There are still no square roots of negatives, so I don't have to worry about those. The only thing I want to find then is where is my second derivative equal to 0 at? And from here I get x equals 1/2. So if you truly want to justify where you have a point of inflection, you should show that at where x equals 1/2, your graph changes from concave up to concave down. We don't really need the table to justify whether we have maximums or minimums, because we can just plug in our first critical numbers into our second derivative to tell us whether in a region of concave up or concave down. So let's deal with maximums and minimums first, and then let's deal with the point of inflection. So the two thoughts we're going to combine is where do you have 0 slopes, and if you have a 0 slope, what kind of concavity do you have there? So what is f double prime of 3? So when you put 3 where your slope is 0 at, the x value is 3, into your second derivative, you get the number 5. So your thought right now is that my second derivative is positive. My first derivative is 0. So if you want to picture that, what you should be doing is saying I have a concave up section to my curve, because where the number is 3, it's positive. You don't know if you have the increasing decreasing thing, but you do know you have a 0 slope. So when you understand derivatives, second derivative is positive, first derivative 0, that now tells you about the function that f of 3 is the minimum. Okay, and that's the neat part about the second derivative test. Right? You combine two thoughts together to help you figure out the puzzle, help you figure out the problem. And let's do the same thing with our other 0 slope. Take your negative 2 and put it into the expression as well. So what is the second derivative of negative 2? I'm thinking that's negative 5. So let's go through that same kind of 1, 2, 3 process. First thought, my second derivative is negative, which means it's concave down. Another thought is my slope is 0, so it has to be at that point. And then the last thing I get to say is that when I put negative 2 in there, it has to be a maximum. So without any kind of table, without any kind of increase-decrease table, we're going straight to the idea that negative 2 is a maximum, f of negative 2 is a maximum, f of 3 is a minimum. And if you want to find the actual values, you go all the way back up to your function, because the function tells you the x, what x is, and then replace it with your known y value. So we have a maximum, we have a minimum. We're supposed to figure out where our point of inflection is. Do we really need to show the table? We know that we have a region that has concave down. We know we have a region that's concave up. So we can probably, without a table, justify that our point f of, was it 1/2 or negative 1/2? That f of 1/2 is a point of inflection. And our logic there is that that's where the second derivative is 0. And we have that concave up, concave down thing happening. Right? If you kind of look at going from left to right, our graph is going from concave down to concave up. So what else do we have to do? Maybe find some numbers. So we were supposed to actually find the maximum minimum values. So we want to make sure we do that. We actually want to find a point of inflection. So we actually got to find our y values for all those x values. And then we want to draw a sketch. So here where we said, what is f of negative 2? Find f of negative 2. It says find f of 3. Let's actually plug in f of 3. And where that's f of 1/2, let's plug in f of 1/2. What was the rest of it? Is that right so far? And plus 1. So put a 1/2 in there and work it out. And this would be a great time for you to test your fraction skills. This would be a great fraction question to do. Negative 2 and 3 as well. Okay, so we went through all that hard work to figure out our points. Really, when it comes time to sketching things, what's most important is we know you have the maximums, you know you have the minimums, and if you look where your maximums and minimums are, if you can draw a sketch that's at least close using those numbers. 3 is the minimum. So the right side of the y-axis is the minimum. Something else you'll look at is you have a point on the y-axis at 1. You've got a minimum over here, and you've got a maximum over here, and somewhere at 1/2 you have a point of inflection. So there's another point here. So we want to just make all these things kind of go together. And that would be your sketch. Okay, so again, we want to look at a point of inflection. Where is it at? It's on the right-hand side of the curve. The minimum's on the right-hand side. And again, of the curve, we're talking about being on the right-hand side of the y-axis and make it look pretty. And that's it.